Okay, so this is 1.5a that we're doing today. And it's exploring angle pairs. So it's all pairs of angles. What's a pair? 2, right? So 2 different angles that we're going to compare to each other, relate to each other, something along those lines, okay? So the first one is adjacent angles, and that's the definitions here. 2 coplanar angles with a common side. So there's 3 things: common side, common vertex, but no common interior points. So basically, adjacent angles are going to share a ray, and that's it. They won't share anything else. So it might look like this. Okay, if this is angle 1 and angle 2, the only thing they have in common right now, that's not what I want, is this ray right here. Oh, that kind of takes it away, doesn't it? We'll put it back in. We're still on yellow. So that ray is their only commonality. There's not going to be any points between the 2 that are the same. Okay? Or it could look like this. Angle 3 here, angle 4 here, those would be adjacent. Okay? The only thing they share is this right here, that ray with the point where they meet. Okay? No overlapping. Then there's vertical angles, and vertical angles we'll talk a lot about. You'll see a lot of in this class. We're not necessarily talking a lot about them, but you will see them a lot. And vertical angles are just 2 angles whose sides are opposite rays. So do you remember what opposite rays are? They go in opposite directions, right? So it's like this. One's going straight right, the other one's going straight left. If one's going straight up, the other one's going straight down. Okay, those are opposite rays. So for instance, if this is my end point, I could say those are opposite rays, right? So vertical angles have 2 sets of opposite rays. So we would say angle 1 and angle 2 are vertical angles, okay? Or angle 3 and angle 4 are vertical angles. Any guesses what might be true about those angles? In terms of their size, how about? How do you think 1 compares to 2? Or how do you think 3 compares to 4?
They're both obtuse.
3 and 4 are both obtuse. 1 and 2 are both acute, okay? More specific than that even, they're equal. Yeah, they're congruent angles. So we would say like angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So when they're vertical, they're also equal, which we're not going to deal a lot with, but we will talk about from time to time. Angle 3 congruent to angle 4. Okay, so that's vertical angles. Then we have complementary angles, and this is not like a compliment, like your hair looks nice today. That's not that kind of angle. It's complementary angle with an E. Yeah.
Is it like one angle will give you the same, like, they'll be the same degree?
Not the same degree, but the 2 of them together always add up to the same thing. Anyone know what that is? Have you heard of complementary and supplementary?
Yeah, I've heard of those 2. But
Yeah. So here's the deal. With complementary angles, they're going to have a sum of 90. And that can look like several different things. It could look like this. Okay, so angle 1 and angle 2, we would say those are complementary if this is a right angle. You know how to mark a right angle with the little box in the corner? That means 90 degrees. Okay, so if this is a 90-degree angle, then those are complementary, but they don't have to touch each other, because we would say these are adjacent too, right? They share that ray in the middle. They don't have to be. I could do an angle here that's 40 degrees, and another angle here that's 50 degrees. And we would say those are complementary angles because 50 plus 40 equals 90. Okay, so as long as the two added together equal 90 degrees, they are complementary. So they can be next to each other, but they don't have to be next to each other. Okay. So then that takes us to supplementary angles, and supplementaries have to add up to 180 instead. What is 180 degrees? A line. So supplementary angles might look like this, where you have a straight line and there's an angle drawn in. So like angle 1 and angle 2, because they form a straight line, we would say those are supplementary angles. Okay? Or, like we said with complementary, they can be totally separate. So I could do that this is 120 degrees. And this is 60 degrees. And because 120 plus 60 is 180, because they add up to 180, they are supplementary angles. Okay, so it's going to be two angles that add up to whatever our number is, 90 or 180. Okay, questions on that? Okay, this we're going to come back to because I'm going to draw you a picture here and we're going to figure out a few things. And I changed, yours looks a little different than mine. Yours has all three and a little more spacing, hopefully, right? So this is things you can conclude without markings. Basically what it comes down to is in geometry, you're not allowed to assume anything. Like you have to be told, or you have to be shown markings, or there has to be some information that says these things are congruent or these things are fill in the blank, okay? But there are three things that you can conclude without markings, okay? And one of those is adjacent angles. So if I'm looking at a picture and I see this, okay, they don't have to tell me those are adjacent. I can see it, right? Whereas something we can't see is congruence. I can't just look at two angles and say, I know those are congruent unless it's marked for me, right? Unless they put the little arcs in my angles. But with adjacent angles, I can see it. I can see that they share a vertex. I can see that they share the side. Those are adjacent angles, okay? Second thing that you don't need any markings for is adjacent supplementary angles. So for this one, to be adjacent and supplementary, they're going to form a straight line, but then you're going to have an angle somewhere in there, like this, angle 1 and angle 2, okay? So these would be adjacent supplementary angles. I don't need them to tell me these two angles add up to 180. I can see it. Okay, so you're allowed to assume 1 plus 2 equals 180 because there's a straight line there. Okay, so those are the first two things you don't need markings for. The third thing that you don't need markings for, and I have to go to a different page for this. Well, let's go back then. We'll just write it down. So number 3 is vertical angles. So for this one, I can just look at a picture like this. 1, 2, 3, and 4. And just looking at that picture right now, I can say 1 and what are vertical angles? 3. Angle 1 and angle 3 are vertical. Okay, so I don't need markings, or they don't have to tell me 1 and 3 are vertical. I can say I know it's true. Okay, so there's 3 things that you don't need given information on. Okay, so if that's the case, here's your last example, and then I'll give you some time to work. I'm going to draw you a picture. And you're going to tell us everything that you know in this picture based on those three things that I just gave you. Okay, if this is my picture, tell me what you know is true, either from the list of things I just gave you, those three things. Do you have adjacent supplementaries? Do you have adjacents? Do you have vertical angles? Or based on markings that you see in the picture. So what markings do you see right now? What is marked for you to tell you something about this picture? Not the numbers, anything but the numbers.
1 and 2 have those lines.
Right, what do those lines mean? They're congruent. Okay, so one thing that you can say about this picture is angle 1 is congruent to angle 2. Because it was marked for you, right? They told us it was true. Okay, the rest of them are not marked, but there's still a lot of things that you can tell me about this picture. How about adjacents? Let's start with adjacent angles. How about if I start with angle 1? What's adjacent to angle 1? What does adjacent mean? Next to, right? So what's next to angle 1? Angle 2, okay? So for adjacent angles, angle 1 and angle 2 are adjacent. Is there anything else that's adjacent to angle 2? Angle 3, right? If we just keep working our way around, angle 2 is adjacent to angle 3. Angle 3 is adjacent to angle 4. Angle 4 is adjacent to angle 5, and angle 5 is adjacent to angle 1. Okay, so we know all of that just based on looking at this picture. They didn't tell us, we just know it. Okay, and then the last things that we know, well, there's one pair of vertical angles. Do you see vertical angles? Which ones are vertical angles? So basically the angles that are directly across from each other. 5 and 3, okay? So we can say angle 5 and angle 3 are vertical angles. And then the last two sets are adjacent supplementary. Okay, so what are adjacent supplementary? Which two angles are next to each other and add up to 180? Five and three are verticals.
Oh, no, so that'd be 5 and 4.
5 and 4. So these two form a straight line, right? Oh, sorry. Form a straight line here. Okay, so we would say angle 5 and angle 4 are adjacent and supplementary. There's one other pair of those. What's the other pair? 4 and 3. So angle 5 and angle 4 and angle 3 and angle 4, right? Because 3 and 4 together form this straight line. So those are going to be adjacent supplementary too. Okay. Any questions on that? Ignore the little list at the bottom for now. Here's our first example. Bear with me while I draw you a picture. So this is going to be A, B, C, D, E, and F. This is 28 and 62 and 118. Okay, so let's say we're looking at this picture. If I ask you, are angle BFD and angle CFD adjacent? Okay, take a look at which two angles we're talking about here. So if I highlight angle BFD, okay, what's my vertex on BFD? The F, right? So the angle from BFD would be all of this. Can you see that? Yeah. So that's BFD, right? They also said CFD. So from C to F to D, C to F to D would be all of this. Okay? The question is, are those adjacent angles? So if you think about the definition of adjacent, it says a common vertex, a common side, no common interior points. Who thinks yes, those are adjacent? Who thinks no, they're not? You think no? Any other opinions here? Yes or no? Yes or no, Hope? Don't know. Justin, yes or no? Adjacent or no? BFD and CFD, are those adjacent? So they have to share a vertex, share a side, and have no common interior points. So no points in common other than the side that they share.
Yeah.
Okay, but look, because BFD included all this, right? So anywhere there's overlap inside the angles means they are not adjacent, right? So because all of this is overlapping, the green and the yellow, then we say no, these are not adjacent, okay? So this is no. Oops, back to my pen here. Because they have overlapping points. Okay. Okay, how about this? Can we say that our angle AFE and angle BFC complementary? So first of all, what does complementary mean? They add up to what?
They add up to 90.
90. Complementary is 90. Okay, so if we look at these angles, AFE, right, goes AFE. How many degrees is that angle? 62. Okay. BFC goes from B to F to C. How many degrees is that angle? 28.
So then yes, it is.
Why?
Because 28 plus 6.
Right. If I add those two together, I get 90 degrees, which is the definition of complementary, right? So the answer is yes, those are complementary. Okay. Any questions on that? Okay, back to our list then, because it didn't move over for me. Oh, it's not even here.